We ourselves generate the world. The world is self-generated.
Have you ever felt trapped in a repetitive existence, as if reliving the same day over and over? What if this isn't mere déjà vu, but a sign of a deeper cosmic rhythm? Renowned physicist John Wheeler's groundbreaking theory suggests our lives might be caught in an eternal loop, a divine time loop, unbeknownst to us. Take, for example, a woman named Sarah who wakes up to the same song on her alarm clock every morning, only to find that the day unfolds in an eerily familiar pattern. The same news headlines, the same conversations with colleagues, the same dinner burnt in the oven. At first, she dismisses it as coincidence, but as days bleed into identical weeks, she starts to notice subtle discrepancies. A different colored car parked across the street, a new book on her neighbor's shelf. Desperate to break free, Sarah begins to experiment, making different choices, large and small, hoping to disrupt the cycle and alter her reality. But is this really plausible? Critics argue that the idea of a time loop contradicts our linear experience of time and raises paradoxical questions about cause and effect. If we're reliving the same events, how can we have free will? Wouldn't any changes we make simply reset with the next iteration of the loop? In this exploration, we'll delve into the minding evidence and grapple with the counter-arguments. Quantum experiments seemingly defying time, ancient wisdom hinting at cyclical existence, and the potential for our choices to rewrite the past. Are you ready to break free from the ultimate prison of reality, or are we forever bound to repeat the cosmic drama? Consider our universe, with its countless stars and galaxies, as an advanced simulation. Envision yourself completely immersed in a hyper-realistic video game, where the graphics are so advanced, the characters so lifelike, that the line between the virtual and the real blurs. But what if that's all our reality is? A sophisticated program running on a powerful computer in some unknown dimension? This is the essence of the simulation hypothesis, and it's not as far-fetched as it sounds. Leading scientists and philosophers like Nick Bostrom at Oxford University seriously entertain this possibility. Reflect on how far video game technology has come in just a few decades. We've gone from blocky pixels to photorealistic environments that can fool the eye. Now, project that progress centuries, even millennia into the future. Could a future civilization develop the computing power to simulate an entire universe, complete with conscious beings who are unaware of their digital nature? Picture a civilization millions of years ahead of us, their mastery of technology surpassing our wildest dreams. They might have computers the size of planets, powered by the energy of stars, capable of generating countless simulated universes. Just as we create virtual worlds for entertainment and research, this advanced civilization might be running simulations to study history, explore different possibilities, or simply for the sheer joy of creation. The evidence, while subtle, is intriguing. The universe operates according to precise mathematical laws, much like the lines of code that govern a computer program. And the strange behavior of subatomic particles, which seem to only exist when observed, is reminiscent of how a video game only renders what's on screen to save processing power. Could our reality be a kind of on-demand rendering, only materializing as we perceive it? However, the simulation hypothesis faces significant challenges. How could we ever prove or disprove it? And wouldn't a simulated universe require a real universe to exist in the first place, leading to an infinite regress? Critics also argue that it simply shifts the question of existence without providing a true explanation. If we are living in a simulation, what happens when we die? Could death be just a glitch in the program, a reset button that sends our consciousness to another version of the simulation? This is the concept of quantum immortality, and it's closely linked to the many worlds interpretation of quantum mechanics. Visualize yourself facing a life or death situation, like crossing a busy street. According to the many worlds interpretation, the universe splits into two at that moment. One where you make it safely across, and one where you don't. Your consciousness, however, continues in the universe where you survive. This branching happens with every choice, every moment, creating an infinite web of parallel realities where a version of you always persists. It's like a cosmic choose-your-own-adventure story, where every possible ending is played out and your consciousness flows through the branches where you live. This challenges the traditional view of a single, finite life and opens up the mind-boggling possibility of an eternal, multiversal existence. Contemplate a vast, interconnected network of universes, each representing a different outcome of every possible choice. In one universe, you might be a celebrated artist. In another, a struggling musician. In yet another, you might have never been born at all. Quantum immortality suggests that your consciousness, like an eternal flame, continues to flicker in the universes where you exist, experiencing all the possibilities of your life, and indeed, all the possibilities of reality itself. But the idea of quantum immortality is not without its detractors. Some physicists argue that it's untestable and relies on a speculative interpretation of quantum mechanics. Others find it ethically troubling, as it implies that countless versions of ourselves are constantly dying in other universes. If our world is a simulation, how is everything connected? The holographic principle offers a compelling answer. Picture a movie projected onto a screen. The movie appears three-dimensional with depth and movement, but it's actually encoded on a flat, two-dimensional film strip. Similarly, our universe might be a 3D projection from a 2D surface, a hidden dimension where all the information about our reality is stored. Consider a security chip on a credit card. It appears flat, but it holds a vast amount of information in its holographic encoding. Similarly, the holographic principle suggests that the seemingly 3D reality we experience might be encoded on a 2D surface at the edge of the universe, like a cosmic boundary containing the blueprint for everything within. This idea is supported by the strange phenomenon of quantum entanglement, where two particles remain instantaneously connected, no matter how far apart they are. If reality is holographic, these entangled particles aren't truly separated. They're just different points on the same underlying 2D surface, like 2 points on a piece of paper that remain connected even when the paper is folded into a complex 3D shape. Yet, the holographic principle remains a theoretical concept with limited experimental support. Critics point out that it doesn't explain how the information is encoded on the 2D surface, or how consciousness arises from this holographic projection. The idea of a predetermined reality, whether a simulation or a time loop, challenges our notion of free will. Are we truly the authors of our choices, or are we merely actors following a script? Quantum physics adds another layer of complexity to this age-old debate. Neuroscience suggests that our brains might make decisions seconds before we become consciously aware of them, implying that our sense of agency could be an illusion. Consider a choose-your-own-adventure book. You feel like you're making choices that determine the story's path, but in reality, all the possible outcomes are already written. Similarly, our lives might feel like a series of free choices, but if we're in a simulation or a time loop, these choices might be predetermined, part of a larger narrative that's already been set in motion. Envision a train on a track. The train appears to be moving freely, but it's confined to the path laid out by the tracks. Similarly, we might feel like we're making free choices, but our decisions could be predetermined by factors beyond our conscious awareness, like a pre-programmed script in the simulation or a predetermined path in the time loop. The concept of retrocausality, where the future can influence the past, further complicates the issue. Could our future selves be subtly influencing our present choices, guiding us along a predetermined path? However, Many philosophers and scientists maintain that free will is essential to our understanding of morality and responsibility. They argue that even if our choices are influenced by unconscious factors, we still have the capacity to deliberate and make meaningful decisions. What if consciousness is not limited to our brains, but is a fundamental property of the universe itself? This is the essence of panpsychism, the idea that everything, even inanimate objects, possesses some degree of consciousness. If consciousness is woven into the fabric of reality, we might be able to tap into its vast potential and transcend the limitations of our ordinary perception. Contemplate a single drop of water in the ocean. It contains the essence of the entire ocean, but in a limited form. Similarly, our individual consciousness might be a small part of a larger universal consciousness, a vast network of awareness that permeates everything. Ponder this. Our brains are like radios tuned to a specific frequency, receiving a limited range of information from the universe. But what if we could adjust the dial, expand our awareness, and access a wider spectrum of reality? Practices like meditation, mindfulness, and deep introspection can help us do just that, allowing us to connect to the deeper layers of consciousness and potentially influence the quantum realm through intention and focused awareness. But panpsychism faces significant hurdles. How can we measure or even define consciousness in inanimate objects? And how does this universal consciousness interact with the physical world? Critics argue that it's a philosophical leap with little scientific basis. Envision your mind as a portal to an infinite library of ideas. Quantum physics suggests that our thoughts can access other universes, drawing inspiration from countless possibilities. This could explain those moments of sudden inspiration, where a brilliant idea seems to appear out of nowhere, or those intuitive flashes of insight that defy logical explanation. Visualize an artist staring at a blank canvas, suddenly struck by a vision of the masterpiece they will create, or a scientist grappling with a complex problem, suddenly receiving a flash of insight that leads to a groundbreaking discovery. These moments of creative inspiration might be glimpses into other universes where different possibilities have already been explored. Perhaps when we engage in creative activities, we're not just generating new ideas from within our own minds, but tapping into the vast network of possibilities that exist in the multiverse, as described by the many worlds interpretation. It's like accessing a cosmic internet, where we can download information and inspiration from an infinite number of sources. However, the idea that our minds can access other universes is highly speculative. Neuroscientists argue that creativity can be explained by the complex interactions within our brains, without resorting to multiverse theories. John Wheeler, a pioneer in quantum physics, proposed the idea of a participatory universe. This theory suggests that we are not merely passive observers of the universe, but active participants in its creation. Every observation we make, every thought we have, contributes to the unfolding of reality. Consider a group of musicians improvising a jazz piece. Each musician contributes their own unique notes and rhythms, responding to the others in real time, co-creating a dynamic and ever-evolving musical experience. Similarly, we might be participating in a cosmic improvisation, our thoughts and actions influencing the unfolding of reality. Visualize a painter standing before a blank canvas. The canvas represents the universe in its state of potentiality, a sea of infinite possibilities. With each stroke of the brush, the painter collapses these possibilities into actualities, bringing the painting and the universe into existence. In this sense, we are all artists, co-creating reality with our awareness. However, the participatory universe raises questions about the nature of observation and the role of consciousness. Does it require a conscious observer to collapse the wave function, or are there other mechanisms at play? Critics argue that it anthropomorphizes the universe and blurs the lines between subjective experience and objective reality. What if we are trapped in a divine time loop, reliving the same life or variations of it over and over again? This concept, while seemingly fantastical, finds resonance in various cultures and philosophies. Ancient Eastern traditions, such as Hinduism and Buddhism, have long embraced the concept of cyclical time, with the universe undergoing cycles of creation, destruction, and rebirth. The Greek Stoics also believed in a cyclical universe, with events recurring in an eternal loop. This cyclical view of time aligns with the idea of a block universe proposed by some physicists where all moments in time exist simultaneously, like a DVD where all the scenes exist at once, but we experience them in a linear sequence. Picture a record player stuck on repeat, the needle tracing the same grooves, the same melody playing endlessly. This is what it might be like to live in a time loop, the same events recurring in an eternal cycle. But unlike a record, our lives might have subtle variations with each repetition, offering the potential for growth and change. Quantum physics offers a modern perspective on this ancient idea. The cyclical nature of subatomic processes, the possibility of time not being linear, but a dimension that loops back on itself, and phenomena like déjà vu and precognitive dreams, where we seem to experience events outside of the normal flow of time, all hint at the possibility of a cyclical existence. Perhaps these experiences are glimpses into other iterations of our lives, echoes from past or future loops in the eternal recurrence. However, the idea of a time loop clashes with our intuitive sense of time as a linear progression. It also raises thorny questions about free will and the meaning of life. If we're destined to repeat the same events, what is the point of striving or making choices? Our everyday experience tells us that time flows linearly, from past to present to future, like a river flowing towards the sea. But quantum physics challenges this intuitive understanding. Experiments show that subatomic particles seem to know the future, reacting to events before they happen, suggesting that time might be more fluid than we perceive. Perhaps our lives are not a linear progression through time, but a collection of simultaneous moments, all existing at once. This perspective, known as eternalism, suggests that the past, present, and future are all equally real, and our consciousness moves through this timeless reality like a spotlight, illuminating different moments on a stage. Envision a film strip with all the frames laid out side by side. Each frame represents a moment in time, and all moments exist simultaneously. Our consciousness, like a projector, illuminates one frame at a time, creating the illusion of movement and progression through time. But eternalism is a radical departure from our conventional understanding of time. It raises questions about the nature of change and the meaning of the present moment. If all moments exist simultaneously, how can we explain the feeling of moving through time? The mysteries of quantum reality are unfolding before us, and we are at the forefront of this incredible journey of discovery. Embrace your curiosity, open your mind to the seemingly impossible, and remember that you are not merely a spectator in this cosmic drama, but an active participant in shaping the universe. By exploring the depths of consciousness and embracing the interconnectedness of all things, we can awaken to our true potential and unlock the infinite possibilities that await us. Even if some of these theories turn out to be incorrect, the very act of questioning the nature of reality expands our minds and deepens our appreciation for the universe. Whether we are living in a simulation, a time loop, or a holographic projection, the ultimate truth remains elusive. But the search for that truth is what makes life meaningful and awe-inspiring.